While he's figuring that out, I can just start introing. So my name is Barbara Liau. I am a co-founder and the CEO of Nomad. And myself and my co-founder, James, will be presenting, talking a little bit about Nomad, state of cross-chain today, interoperability, and what happens when things break, and like why security is important and the trade-offs you need to make. So, do you get it? It's good? We good? Okay. Thanks, Julian. Oh. Okay, so this is me with different color hair. Some people have met me, and I like change my hair a lot. And so if you don't recognize me again, it's fine. I understand. I'm like Superman, changed my glasses, hair color. My background as a JavaScript engineer, I've been in crypto since 2015-16. As an engineer at storage is where I started. It's where I first met James. And we've been working on stuff together since. My hobbies are really just a maximalist. I love doing different things, whether that is playing with my dogs, hanging out, from like crocheting to, I went through like a blacksmith phase for a while, and just trying and doing a lot of things. And I think this maximalist mindset, it really informs a lot of the work that I've done in crypto, which is like all the chains, right? Like there's not any one chain I think that's going to win. And there's a lot of different things that are good about a lot of chains, right? And if you want to follow me, I'm Barbara at Barbara Liau on Twitter. Yeah, and so I would say like it's pretty safe to say that we're chain maximalists. So we've been working on interoperability since 2017. With our first startup was Suma, and really what we were doing is we ended up just doing a lot of cross-chain consulting and working with a lot of different ecosystems and different chains, and that was really great. It allowed us to try a bunch of different things. Atomic swaps between Bitcoin and Ethereum was like the first thing we worked on, and this was something because a lot of the L1s and certainly L2s didn't exist at the time. And so as the world changes, the solutions change, and you need to keep a balance between your ideal theoretical, this is what we would love to see, our ideal world, and then what is possible now, and the reality. And also, people would be like, we want this thing, and we're like, okay, and we build it, and then they're like, just kidding, that's really not what I want. And in many ways, we're kind of like toddlers, and we just don't really know until we get it. And so we have to figure out, are we solving real world problems, and what are the solutions we can implement now? So Nomad is kind of the result of many years of unintentional R&D and experimentation. We've also contributed to the problem right now of fragmentation and everything, and working on solutions to fix that. And so Nomad is an optimistically inspired system built for today, right? We're working towards this goal of trustless communication between blockchains, but we're not quite there yet. And so Nomad is a combination of different things. It's, there's always trade-offs when you build something, and it's a combination of, trading off time, latency. It's not as fast as some solutions, but it's not as complicated as others. There's high reusability, and it's relatively secure in different ways. And I think James, we're going to talk a little bit more about that. So really, our ethos is we want to let devs do something, right? Nomad is really, honestly, we want to be boring in that people are using it, but they don't really know. If you don't have a Nomad shirt, you can get one. But it's stealth mode, right? It's kind of like HTTP. People use it. But no one really cares or knows. They just know that if you're going to build a web application, the way that those messages are passed across, use this protocol. And no one knows, and the value comes from the applications that are built on top of it. That's what, we want to drive that communication, that innovation. And we want, what's my next slide? Yeah, we don't want people to have to worry about that, right? if you just want to drive your car from here to there, you don't want to worry about building the roads, right? Let someone else who specializes in roads do that. And because if you don't, you end up with this crazy Denver like road situation. So where are we? Where's Nomad now? We deployed mainnet in January, so we're on mainnet Ethereum. We're on Moonbeam soon. Oh, I forgot soon TM on Evmos. Once Evmos launches, and then whatever other chain soon TM, as is everything. So you can keep an eye out for where we're going. So how did we get here? So it's just a bunch of chains, right? But they're all different in some way. Some of them are groups of chains. Some of them are like whatever chains. And some of these chains were built really kind of in isolation. You know, they have their own ecosystem. They weren't, oh, my notes are in the corner too, it's fine. So, you know, they were trying to solve a specific problem, but communicating with other blockchains wasn't a priority. It wasn't something that they thought about. It wasn't part of the design. So it's relatively isolated. And so now they're like, well, how do we, I think those notes are on every single slide now. You know, how do we, they haven't solved that problem from the beginning. And then there are like ecosystems of ecosystems that thought about like, oh, hey, chains are gonna happen. Like, let's make sure that we build this communication into the chains. So like, you know, IBC, if that's built into it. And that really is a great solution. But if you didn't have that from the beginning, it's really hard to implement after the fact. So, you know, where does that leave us? And even if that was the case, right, you have like something like Cosmos, Polkadot, like, you have those, but how do those talk to each other, right? So you still have the problem. It's just a little like one layer moved. And so we still have this communication problem. It's a bit of a mess. And everyone wants to talk to each other. We're in this like globalization stage of nation states, you know. So what are the different ways? Like talk a little about IBC. This is probably the most, honestly, we're a little bit of IBC maximalist, but we just can't do it now. And as fast as we would want to. But this is the most trustless way. But yeah, the other thing too, it can be a little bit expensive. It's hard to re-implement. But it is very trustless because you basically just replay and verify transactions on the destination chain. Other things that exist right now is external validation. So some trusted third party validates the messages that are passed across. So that can be good because it is faster in many ways, but it relies on also like economic incentives. You know, if there's some group of trusted people or entities, how do you make sure that they are actually doing what they say they are? And so this is great until it no longer is. And so is there a better way? Can you know, what if you could keep an eye on these trusted parties and make sure that they are doing what they're doing? How can you like watch them? And so James is going to talk more about that, and can devs do something to fix?
Thanks, Barb. So I'm more of the technical like co-founder here. I did a lot of the protocol design for Nomad and for a bunch of cross-chain things before that. I've contributed to TBTC, to Aurora, Nears VM, looked at the wormhole architecture, and have been working in cross-chain stuff for just like 5 years or so, way before any of this was cool or fun or interesting. So I want to go through and real quick talk about how bridges break and kind of the ways that they informed the design of Nomad. So we have a few of these that are very high profile lately, and they've all broken in specific ways in this cross-chain message lifecycle. So in order to process a message from one chain to another, there are 3 phases. You start off on the sending chain. The message is sent by some dApp. It is committed to that chain state, and then off-chain actors take over for phase 2. So this is your Oracle or your multisig or your IBC light client relay maintainers. And what happens off-chain is that these people see the message, they decide whether or not to forward it, and they dispatch a transaction to the second chain. So you start off on the first chain, and an off-chain actor takes it over to the second chain, dispatches a transaction. The second chain processes that transaction, and hopefully the message is received by whatever cross-chain DApp you're trying to interact with. Every bridge works this way. Every cross-chain communication system works this way. So we can talk about specific bridges. This was a while ago. Thorchain suffered an $8 million hack middle of last year. So how did Thorchain break? It broke in the part where the message is committed and then seen. What happened with Thorchain is that the off-chain actors thought they saw a specific message, and in fact, the message that was sent was different. So the contract for Thorchain correctly emitted an event saying that no value had been sent. But the off-chain actors, after seeing that event, went and looked up the transaction and saw that the transaction had value and overwrote the 0 with the transaction's value. So they incorrectly parsed the transaction in the Ethereum blockchain, and that resulted in them seeing the wrong message and dispatching the wrong transaction over on Thorchain. So specifically, sorry, I made too many slides for this, so I'm skipping forward really quick. So Thorchain broke where the off-chain actors saw the wrong commitment because they had custom blockchain parsing logic in their node client. So the lesson here is that chain VMs are hard. They taste bad, and we don't want to work with them. Any chain-specific handling code that you write for your bridge, anything that is like specifically for the EVM, specifically for any Cosmos VM, is going to be really brittle and terrible. And chain-specific logic should generally be handled by the chain itself. Your EVM-specific logic should be handled in the EVM. Doing it off-chain, doing it in this parsing layer in your node is a mistake, and it's the mistake that Thorchain made. The next really notable one is Polymarket. Not Polymarket, excuse me. I always make this mistake. Polynetwork. Polynetwork suffered a hack of over $600 million, which is really impressive considering that I had never heard of them. How can there be someone that you've never heard of with $600 million in this space? It just doesn't make sense. So Polynetwork also had a very interesting break, but it was on a completely different part of the life cycle. Polynetwork works kind of like this. An incoming message is signed off by the Oracle. They dispatch a transaction to Ethereum or wherever. After the Oracle signs off, it goes to the Polynetwork system. The system is responsible for forwarding that data to the actual smart contract that's supposed to process it. So it forwards the value and the data from the message onto the actual recipient of the message. So what happened with the attack was that the attacker, cleverly said, I can just send a message to the Polynetwork bank vault, and I can have that message give me all of the money. So in this case, the Polynetwork bank is owned by the Polynetwork system, and the system had complete control over all the money, and the attacker realized that the Polynetwork people never actually validated that the message was a system message and not a user message. So it's the most interesting user account privilege escalation that I know of in the EVM, and it broke in the latter part of the stack. And then the lessons here are that you need a strict layer violation. They confused a system message for a user message. So how can we build cross-chain bridges with a strict layer system? You separate the application logic from the communication logic. Okay, the last one we're going to cover, and I'm going to talk really fast for this, is the wormhole exploit from a few weeks ago. A few weeks ago? How did wormhole break? Wormhole, really interesting, broke between the communication with the off-chain validators and the on-chain processing. What happened in Wormhole is that a user was able to fake validator signatures and the Solana verifier was broken. This allowed the user to mint a huge amount of ETH on Solana and then bridge that fake forged ETH back to Ethereum and get all of the real ETH out of the bridge. So the interesting thing about this is that the Solana Oracle and the Poly Network Oracle both behaved perfectly through these processes. And the takeaway here is that a perfect Oracle is not enough. A perfect IBC Lite client is not enough. These things break, and when they break, the bugs are in the application. They're in the part that's minting and burning code, or they're in the part that is verifying the Oracle signatures. There has never been a compromise of a bridge's root of trust. No one has ever stolen the Oracle's multisig keys. No one's ever broken the IBC Lite client implementation. 100% of bridge hacks have been breaks in the application code, not in the trust model. So it kind of follows that the only thing we can do about this is not like build a better bridge with a cooler trust model and a big proof of stake system or something. The only thing we can do about it is insert financial controls into the off-chain portions. So this is why Nomad has a delay in transmission, is to allow us to insert controls. Off-chain actors who are watching the system, and for each message asking, is this message real? Was it actually committed by the sending chain? Is the origin faulty? Is there some issue in Solana that's not validating signatures properly that means this message shouldn't be sent back to Ethereum and steal all the ether? And will the recipient behave as expected? When there are messages going to the Poly Network system contract or the bank contract, are those messages going to have the effect that the developers intended and expected? All of these questions can be answered off-chain before any of the, before we make these processing transactions on the receiving chain. So the lesson here is that bridges will never be perfect. The perfect Oracle, behavior that we've seen so far has been great, but everything breaks in the application layer and all the money ends up getting stolen, even though the bridge security model is perfect and not compromised. So the only thing we can do is write better code, separate the application and the communication in the code, and have explicit, in-depth, off-chain checks and balances for our bridges. So that's all I have. I am unsure if we have time for Q&A. Nope. So you can find me probably by the bar after this. Thanks so much, everyone.